This is the second of several videos here about, I guess our goal in these is really to get to the P-series test, which is one of the more useful tests that we have in looking at Taylor series. So what I want you to do, this is your little anti-set, is to calculate these three improper integrals. 1 over x cubed from 1 to infinity, 1 over cubed root x from 1 to infinity, and 1 over x. Now, before you go, let me give you a little tip with this one. When you're doing your power rule, you are going to add 1 to negative 1/3. So try to make sure that you do that right. There is a common mistake with this one. So hit pause. I'll hit pause in a moment and make sure that you do all these, and I will pop the answers up in just a moment. Okay, hopefully you got a half for the first one and then divergent for the next two. Why is this one a half? Well, I take 1 over x cubed, integrate it with some power rule, and then do this, and then this b, I should have a squared here. That b gets squared in the denominator, which means that I go to 1 over a big number, which goes to 0, minus this, which gives me 0 plus a half. Now, these two here, when I integrate them, they become functions, 3 halves x to 2/3. I think the most common error with this one is to have a 1/3 there. But if I go up a full unit from negative 1/3, then it takes me to 2/3. But anyway, that's the same as cube root squared. And if I try to quote plug in infinity to if I square infinity and then cube root it, it's still going to be infinity. So this thing is divergent. And then same with this one, but for a sort of different reason. 1 over x integrates to ln of x, which gives me ln of b as b goes to infinity. And ln keeps increasing and going up and goes to infinity. So this is also divergent. What I want you to see is that it's all about power rule. My question for you is, how could we change that 3, right? Oh, and I guess I should point out that this here is the same as 1 over x to the 1/3. It's kind of important. This has a power of 1. But how could I change this 3? For example, could I change it to a 1/3? Could I change it to a 1? Could I change it to an 8? Could I change it to a half? What happens when I change that power in terms of not what's the number, but when does it converge? Because this one converges on a half. When do these integrals converge and when do these integrals diverge? And I want you to think about what values here would converge and diverge, and it's all about power rule. So let me put some up. All right, 7 integrals here. 1 over x to the 4th, 1 over x to the 10th, 1 over x to the 1.1, 1 over x to the 1.000, however many zeros, 1, versus root x, which is x to the half, 1 over x to the 0.9, 1 over x to the 0.99999, right? Maybe I said 1 extra 9 there. Whatever, that's cool. But which of these will converge and diverge? Maybe you've realized that I actually grouped them. All of these will converge. All of these will diverge. And why is it? It's because of power rule, as I said above. Remember, power rule adds 1 to the exponent. So this is x to the negative 3. When I add 1, I get x to the negative 2, which gives me something in the denominator that grows. All of these are far enough away from which one? From this x to the 1, that they will have an x that remains in the denominator. This will go to x cubed in the denominator. This will go to x to the 9th in the denominator. This will go x to the 0.1 in the denominator. This will go to x to the 0.000001 in the denominator. All of these will have things. If I take, oh my gosh, I can't believe I just did that. I'm not going to redo this, but what I meant I meant for all of these, and maybe you just rolled with it, was to say the integral from 1 to infinity for all of them. So all of these, when I try to plug in, quote, the infinity for these, it's going to have something like this one, where there will be an infinity to some power, it doesn't matter what it is, in the denominator. So all of these will converge. And then all of these here are going to go to, this one's going to give me, this one will give me a 2 root x. When I try to, quote, plug in the infinity, it's going to go to infinity. This is going to give me 1 over 0.1 x to the 0.1. And if I plug in and, quote, plug in an infinity, if I let it go to infinity, this will grow eventually and go to infinity. Even this one, x to the 0.0001, if we let that go to infinity, it's going to go to infinity. Even if I'm dividing it, well, actually that's multiplying it by a pretty big number, but it doesn't matter what number's out front. This will go to infinity. So all of these will diverge, and all of these will converge. And remember, 1 over x to the first goes to an ln, which also diverges. So what I want you to see is that if I take the integral, hopefully you see this at this point, of 1 over x to the p dx, and I'm going from 1 to infinity. I won't leave it off this time. That there are, the p value there is the thing that determines if this integral converges or if it diverges. And it's all because of power rule and that adding 1 unit. So it converges if blank, and it diverges if blank. I want you to put information about the p, the value of p in those blanks. So hit pause, go ahead, do it. Okay, hopefully you wrote, it converges if p is greater than 1. Why is that? Because it will give me this value that will do what these do here, right? Notice all of these are greater than 1. All of these are less than 1. And then you should see that if p is 1, it diverges. So come down here, it diverges if p is less than 1. And now I'm going to say something. So this thing, I think that if you think about it, and if p is a negative number, then the x is going to be in the top, and then I'm going to have the integral from 0 to infinity of something where I integrate an x to the top, right? So I am going to write 0 less than 1. Oh, I messed up. Less than or equal to, right? But this is, if for this x to be in the denominator, p has to be positive. So I'm going to only consider p greater than 0 here. It doesn't really matter that much, but those are the ones we care about. And why is there a less than or equal to sign here? Well, that's because at p-value of 1, it should be clear to you that we integrate to an ln, and then we get something that diverges. This is super important because it's going to take us to the p-series test, but we have to first do the integral test. So the next video is going to be about the integral test, and then we'll get to p-series test. P-series is one that we use all the time. So hopefully this is making sense, and I'll see you in the next video.